Hello everybody, hello there ROS developers, welcome to a new OpenClass. We are today in OpenClass number 181, if I'm not wrong. So hello from Barcelona, and today we are going to be checking on a very interesting topic, a very important topic related to ROS2, which is navigation. So we are going to be applying and creating a basic application based on navigation for a waiter robot in a restaurant, so that we can send it from one table to another. So welcome everybody. Let me know please in the chat if everything is fine, if I can see the video is fine. I'm not sure about the audio. It should be fine also. I can see there Gilbert says that audio is good. Okay, excellent. Then great. So then let's not lose any more time and let's start with the class. So let me switch right now here to my computer screen. There we go. All right. So the very first thing that you have to do, as Gilbert has already mentioned and done, is to get the copy for today's class rosject. Yeah, in case that you are new to open classes, these open classes are practical, are practice based and practice oriented. All right. So meanwhile, I am going to be explaining and showing some things. You are going to be able, and you should, in fact, you have to also practice at the same time with me. All right. So so that you can do this, so that you can also practice. Meanwhile, the class is going on, I am providing this rosject here. So all you have to do in order to get it is to click on this button that you have right above the chat here, which says fork and open the class rosject. All right, I am going to click here myself right now. There we go. And then, so as soon as you click on this button, two things are going to happen. First one is that you are going to be redirected here to the main rosject page, as you are seeing right now. Stop this. There we go. All right. And here at the right side, you are going to have the streaming area with the chat, the video feed, etc. In my case, I'm going to remove this so that I have some more space here to work on the rosject. But let me open the chat and everything here so that I can still see your messages and everything. Here it is. There we go. Okay. There we go. All right. And then, so after some seconds, in some cases it might take up to a minute, the rosject is going to be loaded. Let me also tell you that this rosject that you are opening right now, you are going to have it also in your account. Yeah. In the construct, if you go to the My Rosjects area, you are going to have a copy of this rosject here. What does this mean? This means that you are going to be able to open it tomorrow, next week, next month, in case you want to revisit something, practice with something related to the rosject. You are going to have it there in your account. All right, permanently. Okay, then let me go back here. My rosject is almost loaded. So, have all of you already copied the rosject and you are inside the rosject page? Gilbert, Florencio, Ganesh, people who I can see here in the chat. Yes, Yup. Okay. Opening. All right. So mine is almost there. And as soon as it loads, you are going to be prompted, you are going to see that a notebook is going to be automatically opened. There we go. Okay, let me close all these things here. Yeah, so once the rosject loads, also for you, you should see something like this, a notebook automatically opened. Yeah, so here is where we are going to have all the instructions, a bit of theory, some example codes. Everything that we are going to be doing during today's class, that we are going to be following up, is here. You are going to find it here in the notebook. All right? Yeah. So today we are in OpenClass number 181, and what we are going to do is to do waypoint navigation with a waiter robot. Everything based in ROS2. All right? Yeah. Then the very first thing that we are going to do, okay, before explaining, getting here into what we are going to be doing. So basically we are going to be working with navigation 2, but we are not going to get into detail with navigation 2. Okay, what we are going to do today is to use the simple commander API, which is something new that has been introduced in ROS2. And what this API allows you to is to very easily create applications. In this case, we are going to do it using Python code. You can very easily create applications that directly communicate with the navigation 2 system. Yeah? But let's better see all this with some practice, right? It's always better to see it in action. So the very first thing that we are going to do in order to start with the class is to start a simulation. Yeah, we are going to be starting here a simulation of a restaurant, let's say, with a Turtlebot 3 robot. So in order to start the simulation, all you have to do, very easy, is to execute these commands here. And in order to execute the commands, you need a terminal, right? So let's open a new terminal. And to do this, what you have to do is to click on the button here to do so. Yeah, here in the bottom menu of your rosject, you are going to find several tools. And the first one here, which says Web Shell, if you click here, this is going to open a new blank terminal. Yeah? Now here you can directly copy the commands from the notebook and run them here, paste them here into a terminal and execute them, okay? In this case, this is a bash script, an SH script, but inside it, what we are doing is to basically start a ROS2 simulation based on Gazebo, yeah? So meanwhile the simulation is being loaded, what we can do, if you want, is to open the code editor, yeah? So we are going to be using the code editor also today to create some programs. So let's click on the next button here, right at the side of the web shell, which says code editor. Okay, this is going to open another window here with the code editor, and meanwhile you can see here also that automatically the Gazebo window has popped up here in my screen. Here I have it. Yeah. So here, let me zoom out a little bit. Here I have the simulation of the restaurant with a tiny Turtlebot 3 robot here on the right side. It's going to appear on the screen in a moment. Let me look for it. There we have it. There it is. Okay. So here, as you can see, we have a restaurant-like environment with some tables, etc. Yeah. This is the Gazebo simulation that we are going to be using for today's class. And here also, previously, I opened the code editor. Yeah, this is a tool. All of the windows that you have here, you can resize them, organize them as you want. You can even move them here to another browser tab if you want to bring them out of this tab. So you organize as you want. And then here, basically, what you have is a graphical interface to interact with all the file system of this project. Yeah. For instance, if you go inside the sim workspace, here, inside the T3 Humble, you are going to find the script that we executed for starting the simulation. Yeah. You can open it, have a look at what's going on here. You can see a ROS to launch command, etc. Yeah. But for the rest, we are going to be working with the ROS to workspace. Yeah. If you go inside your ROS to workspace, also you are going to find some packages here. Basically, the important one is the Path Planner server. Yeah. Here we have an already set up navigation to system for the Turtlebot 3 robot. Yeah, so this has been prepared by us. Actually, it has been prepared by Tisas, who has helped me creating this project. Yeah, so the navigation system for the robot is already set up for you, so you don't have to do it. Yeah, this is already working. And I'm not going to go into details about that because it's not the purpose of this course. In any case, I have added here at the end of the notebook a link in case that you want to learn what's going on behind the scenes in terms of ROS2 navigation. You have here a link to our course where everything is explained in detail. Yeah, how to set up a ROS2 navigation system for a robot, for a ROS2 robot. In any case, let's go back here to our notebook. And yeah, so this is the setup that you should have in order to be able to follow the class properly. Yeah, so launch the simulation. Has everybody launched the simulation? Yes? No? Any problems so far? Ganesh says yes. Also Hugo Costel, I think. No problem. Simulation running. Launch it. Okay. Excellent. Now, let's get started. Yeah? So here you have a command in case that you want to move the robot a little bit around using the keyboard. Actually, we can test it very quickly. So I'm going to copy this command and I'm going to go to my terminal, but I'm going to open another one, yeah? Here in the first one, I have my simulation running, yeah? Actually, I can rename this tab to make sure that I have everything organized. So here I have the simulation running. You don't want to touch this one because if you close this one or anything, your simulation is going to die, yeah? So we have to leave this one running, and then what I'm going to do is to click here on the plus button in order to open another one. Yeah. So here I have another new terminal, empty, blank, so I can execute other commands here. For instance, I'm going to execute the keyboard teleop program here. And what is this program for? This is a very common program in ROS and in robotics that basically allows you to control a robot by using the keyboard. Yeah. Let me put this here and put the simulation here. And then here you have the different keys and what they are for. Yeah. So if I press in the key I, for instance, I'm going to move the robot forward. If I press the comma key in my keyboard, I'm going to move the robot backwards. If I press the J key, I'm going to rotate to the left, etc. Yeah, let me show it to you. So right now you cannot see it, but I'm going to start pressing the I key to move the robot forward, and you are going to see in the simulation in the right side how the robot is moving forward. See? I'm going to move backward now. Yeah, so actually the robot is facing outside of the tables. Yeah, I can rotate the robot if I want here to make it look at the tables. I am rotating the robot right now, as you can see. Yeah. This is a bit zoom out, but let me zoom in a little bit so you can see it, because the Turtlebot 3 robot is very small. Yeah. There we have it. But yeah, here, as you can see, I'm going to move forward. Yeah. I can stop with the K. With K, you are going to stop the robot. Yeah. Let me move backward, and so on. Okay. So a very typical program for basically quickly moving the robot around. Okay. It's enough. You can play a little bit with that. I'm going to stop here. And now the important thing here is that we are going to launch the path planner, or basically what we are going to launch is the navigation to system. Yeah. Because we are going to launch the path planner alongside with the localization system, with the map server, etc. So all the navigation to system, we are going to launch it here with this command. Okay? If you are interested, you can have a look at this launch file to check what's going on here, for instance. In this case, as you can see, you have it inside the Path Planner server. Inside the launch folder, you have here the file that we are going to be executing. And as you can see, this is starting the map server alongside with the AMCL, which is the localization system, all the controller server, planner server, etc., etc. Okay? So, what I'm going to do now is to execute this command in the terminal to start the navigation to system. Let me put this a little bit bigger here. And there we go. Okay, there we go. All right, so now, in order to properly set up everything and interact a bit with the navigation system, what we are going to do now is to start RVs. Yeah? I don't know if you are familiar with the RVs tool. So, as you can see here, you are going to start getting some error messages, which this is normal, okay? It's normal because in order to have everything properly working, we have to provide to the navigation system the initial position of the robot, okay? And this is what we are going to do right now. But for that, we need to use RVs. And what we are going to do is to open yet another terminal, yeah? So in the first one, we have the simulation. Now here, let me rename it. We have the navigation to system. So I'm going to open a third one, which actually I'm going to already rename here to RVs, where I'm going to launch RVs here. There we go. So let me paste the command. And this is going to start RVs. There we go. Okay. So initially, you are not going to see anything here, okay? Now, we are going to add some displays here so that we can start interacting with the system, yeah? In order to add elements to RVs, you have to use the add tool that you have right here, yeah? It says add. This is going to allow you to add displays to your RVs window, all right? Then here we are going to add, first of all, the map. Yeah, we want to have a look at the map. So let's add the map here. Then we can do that by topic, by display type. Okay, in this case, I'm going to do it by topic. So I'm going to go here to the by topic tab. All right, and I'm going to select the map down here, okay? This one here, not the coast maps that you are going to find up here, but down here, the map, okay? There you go. And initially, you are not going to see anything. This is because of the quality of service. So in order to properly visualize the map, you have to come here to the topic settings and change the reliability policy, okay? So, now I am going step by step, but don't worry because later I'm going to give you a trick, okay, to do all this faster. But yeah, so we change here the reliability policy of our topic and we change it to transient, no, actually not the reliability, but the durability. You have to change it to transient local. And then suddenly here we can see the map appear, all right? So, another important thing, actually I think that I'm going to tell you the trick already now. So, yeah, here there are some things, but I don't know if you are following all this setup properly. So, in case that you are comfortable working with RVs, you can do it like this. In case you are not, let me give you a trick, okay? I'm going to give you a trick because here, in this project, we have created already an RVs configuration file which has all this done, okay? So you can load it by coming here to the File button in the top left corner, click on the Open Config button, and then you have to navigate here to User, ROS to workspace, SRC, and here you are going to find this path underscore plan.rbis file, okay? You can double click here, click on discard, and then a predefined configuration file for RBs with all the displays already added is going to load, okay? So this is going to be much faster. As you can see here, we already have a display for the map, also for the laser scan, for the TFs of the robot, etc. Okay? So what do we have to do now in order to have the navigation to system working? Does somebody know? What is the first thing that I should do now? Can somebody tell me? We have here a question from Anna Lee McLean. She asks, is it the nav2map server node that publishes the gazebo map so that we can visualize it in RVs? Yes, exactly, Anna. So the map server that we are starting here, this is the one in charge of publishing this map that we can see here in RVs. Yeah, and this is the map that it's going to be used for navigation. Yeah. Okay, so Krishna says AMCL, exactly. So the very first thing that I have to do is to provide the initial pose of my robot. Yeah. So where is my robot? Okay, let me have a look here at the simulation, and the robot is more or less around here, right? Right now. So how can I provide the initial pose of the robot? Well, there are different methods, but in RVs, you can provide the initial pose by using this button here, the 2D pose estimate, okay? If you click here, you can then click again on the map in order to provide an initial pose of your robot. So for instance, I'm going to say that more or less my robot now is around here, okay? Now, when I do this, all the navigation to system is going to initialize, as you can see. Yeah. For instance, I can now see the laser display, yeah, which is these red lines that have appeared here. These are the laser scan readings. Yeah. Also, you can see the map. It's been inflated here. It has changed a little bit. Actually, this is the global cost map. Yeah. Which is a very important system in navigation too. Yeah? And as you can see, right now, the laser readings are not fitting actually the map. Yeah? You can see there is a small error here. But this is normal, okay? This is normal. Why? Because the position that I have provided is not super accurate. Okay? However, if my localization system is working properly, as I move the robot around, this should get automatically corrected. This is a small error, okay? So what we can try right now, if you want, is to send a navigation goal to the robot, okay? For instance, I'm going to use here the 2D goal pose tool that you have also here in RVs available, 2D goal pose, in order to send a goal to my robot. Then I can click here in the map and set a navigation goal for my robot. For instance, I'm going to set this goal. As you can see, here a path is computed. You can see it here in green, and my robot starts going towards the goal. And meanwhile, as all this happen, we should also see that the laser readings are getting corrected. Okay? Yeah, so this is getting corrected slowly, as you can see. It's readjusting everything. Okay, I think that the first goal has been reached, right? Let me check the navigation too. Yeah, goal succeeded. So let me actually send another goal, because I want to improve a little bit more the localization of my robot. Let's send it around here. And this doesn't have to be only by sending navigation goals, okay? So I can improve the localization of my robot also by moving the robot, for instance, with the keyboard teleop, okay? And also what I'm going to do actually is to add here another display right now. So I'm going to add a display in order to visualize the localization of my robot, yeah? So I'm going to click here on the add button, and I'm going to add a particle cloud display here by display type, particle cloud. Let me add this and set up the topic, which is particle cloud, and the reliability in this case has to be set to best effort to properly visualize this, okay? Now, for instance, let me send here another goal for my robot, somewhere around, I don't know, here. See, so now all these red points have appeared here, and all these points are the particles of the localization filter that is being used in order to localize the robot, yeah? All right. And meanwhile, my robot is moving. As you can see, the localization is fixing the error. Yeah. So the laser is adjusting to the actual map position, which means that my localization is actually working properly. Yeah. It can be optimized for sure. But yeah, it is able to localize the robot, yeah, and correct the error on its own, as you can see. All right? Yeah? Have you all been able to send a goal to the robot? Jeff was answering the previous questions, but yeah, you were right. We had to tell the system the initial pose. So have you been able to have the robot navigating like this, sending a 2D goal pose with RVs? Yes, Gilbert says yes. What about the rest? Krishna says yes also. Okay, excellent. Then let's continue. So let's keep going. Okay, so now we have tested the navigation system of our robot and we can see that it is working. All right? So what now? Okay. Now what we want to do is to actually create a program that is going to interact with this navigation system, yeah? So right now we are interacting with the navigation system ourselves from the RVs application, right? We are using RVs to set the initial pose, we are using RVs to send goals to the robot, right? But what we want to do is try to actually create a program that does this, yeah? So this is what we are going to do right now, okay? Okay, yeah, let me come back here. Yeah, so actually, at this point, no, I don't want to stop this yet. So I'm going to leave all this running and I'm going to open a new terminal, a fourth terminal, okay? There we go. And here we are going to create a new package, yeah? Here you have the instructions to do so. So I'm going to just copy paste directly from the notebook, okay? So here I'm going inside the source folder, of my ROS2 workspace, and I'm going to execute the ROS2 package create command in order to create a new ROS2 package named WaiterBot, okay, with some dependencies. Then let me execute this command to create the new package, yeah. And now I'm going to have this package available also, of course, from the code editor. Here I have it. Yeah, this WaiterBot package that I have just created. Then, first of all, I'm going to create a program which is named getCoords.py, okay? So let's go inside the WaiterBot folder of our package here and create a new Python file like this with the touch command. You can also create it directly from the code editor as you prefer. There we go. So here we have our getCoords.py, which right now, of course, it's empty because we have just created this file, right? And now, here we are going to copy and paste the following Python script that you have right here, okay? So I'm going to select the code here from the notebook, copy, and paste here to my code editor. There we go, okay? So here we have our Python script. Then this program right now has nothing to do with navigation yet, okay? So this program is a very basic program that we are going to use in order to get the coordinates of our tables, yeah? The coordinates that we are going to later use in order to send the robot to the different tables, yeah? Then this program is a very basic Python script which is creating a subscriber, yeah? It creates a subscriber to this topic, the clicked point topic, okay? And what is this topic? Where does this topic come from? This topic comes from ROS, yeah? ROS has a tool, you can see it here, which says publish point, yeah? And this allows you to click anywhere in the map in order to publish one point, okay? And where is this point going to be published? It's going to be published in the clicked point topic, yeah? So what I am doing here in my program is to subscribe to this topic, yeah? So I'm going to capture all the clicks that I do in ROS using the publish point tool, right? And then in inside the callback of my subscriber, what I am doing basically is to print these coordinates into the screen, okay? Let me show it to you. So, well, in order to show it to you, I have to run the program, right? So before that, what we have to do is to generate the executable. So we have to add an entry point to generate the executable. This is done by updating the setup.py, yeah, with this section here. So let me open the setup.py of my package here. And inside the entry points, inside the console scripts, I'm going to add the following line here. There we go. I'm going to save. And now what I have to do is to compile, right? So you have also the commands here to do so. So I'm going to copy everything directly to the terminal, paste it, and execute it. Yeah, so here we are building with Qualcomm build the package, the new package that we have created, WaiterBot. All right? There we go. It shouldn't take much time. And then once we have finished compiling, what we are going to do is to execute our program. Okay, here we have the command to do so. So let me come here. There we go. We have finished building. Very important after you build to source the workspace. Yeah. And now finally I am ready to run my program, my get coordinates program. There we go. Okay. So when you execute the program, nothing is going to happen, right? What you need to do now is to come to ROS here, and I'm going to use the publish point tool in order to click where the tables are in my map, yeah? Let me show a quick example. So I click here in the tool, and then I'm going to click here. Yeah, here we have one table, so if I click here, there we go. Now, if I go back to my terminal, I can see here the coordinate has been printed, right? And I can repeat the same process with all the tables, right? So publish point, here there is another table, right? Here there is another table, yeah? There we go. Okay. And here now I can see all the coordinates of my table. Yeah. And I am going to use this later for my program. Okay. This is just a helper script in order to quickly get the coordinates of the table. Okay. So I'm going to only create 3 coordinates. We don't need to create more for this example. So at this point, we can already stop the program. I'm going to stop it here. There we go. And yeah, actually, I think I'm going to stop everything to start from 0. Yeah. So by the way, everything that I am doing is here. You have it, everything explained step by step in the notebook. Okay. I am skipping most parts of the notebook because I already know what's in there. But in case that there is something that you miss, that you want to review, you have everything that I am doing. You have it explained here step by step in the notebook. Okay. Let me have a look here at the chat. I can see some new messages. As localization narrows down, there is an error. What's actually being adjusted? The transform from map to base link through ODOM. Oh, I can see here Girish also is or actually answering this. Yes, okay, this is very interesting. So the particle cloud can be thought of as all the possible places the robot could be? Yes, exactly. So all these points that we can see here, all these red points that you can see here are guesses of the robot position. Yeah. So as localization gets better, we should see all these points narrowed down. Okay. This would mean that the localization system is working. Yeah. If they are very spread, that's a bad sign. Okay. Not places location, but poses aka position and orientation. Exactly. In fact, let me show you something. Yeah, because here you cannot see it. But if you zoom a lot, you are going to find out that actually these are arrows. Yeah? So this is providing position and orientation information. Yeah? Okay. More questions? Are we good to continue? Okay. I don't see any more questions for now, so let's keep going. Okay. Now, all right, so basically now what we have done is to create our Python script, and we have executed our Python script in order to get the coordinates of the table, which we have here. Okay, I'm going to use them later. Now, what I'm going to do is to actually create the application for the weighted robot. Yeah, and for that I'm going to use the simple commander API for navigation 2. Okay, then right now we are going to create a new Python script. Okay, inside our waiter bot package. So let's do that. Let's create a new Python script named waiterbot-navigator.py. And inside this script, which I have here, we are going to copy and paste the following code. Okay? This code that we have here, that we are going to review in a moment. Okay? So let me copy and paste this code here. Okay. So let's have a look now at what is going on here in this Python script. All right? So first of all, we have some imports, as you can see. We are importing some messages, libraries, things that we are going to be using inside our program. Okay, and then we initiate the Python client library for ROS2, so that we can create ROS2 nodes in Python. And then here we initialize the basic navigator, which is going to create the connection to the navigation 2 system. Okay? Now, with this instantiation of the basic navigator, I'm going to be able to call methods from the API to interact with the navigation system. Okay? You're going to see that in a moment. So, right down here we have some coordinates. Yeah, these are the table coordinates, and actually here is where I want to use my information, right? So actually I'm going to get rid of all of these except 3, and here is where I'm going to put the coordinates that I obtained earlier, right? Let me we don't need to use all the decimals, so let me just get a couple of decimals. So there we go, minus 2.95 and minus 6.16. Actually, we don't need the Z coordinate, right? So we are working with a robot that is basically in the ground. So actually, you can get rid of the Z coordinate. Okay, we can only use the XY coordinates in this case. This is basically a 0, right? So I'm going to write a 0 here. For the second table, there we go, and the other coordinate is minus 4.17. Let's put this here, there we go, and I'm going to remove also the Z coordinate. And the third table that I captured is this one, it's 2.81, and the Y coordinate is minus 1.96. And let's also remove here the Z coordinates. There you go. Okay, I think everything is correct now. Minus, yep. All right. So here I have set the coordinates for my tables, the tables of my restaurant. Okay. What else? What are we doing here? Here we are basically using the API to initialize our robot position. Yeah. If you remember, earlier we used RVs and the 2D pose estimate tool in order to provide the initial pose of our robot. Here, we don't need that, actually. We can do that programmatically from the code. Yeah, so this is what we are doing basically right here. Yeah, so we are providing an initial pose based on the map frame. Yeah, and we are using the set initial pose method from the navigator. Yeah, remember that we initialized it earlier. We use the set initial pose method, and we pass to this method the pose of the robot. Okay, this pose actually is where the robot starts when we restart the simulation. So at this point, what I'm going to do is to stop everything. Actually, okay, I'm going to stop everything to restart the simulation. Let me do that here. And let me close here the simulation, which should get rid of everything. Let me make sure of that, because in some cases Gazebo doesn't close properly. So, sorry. So I want to make sure. Damn it. I need to change here to Spanish keyboard. There we go. Okay, yeah, everything was closed properly. So if you stop the simulation, in order to restart it, all you have to do is to execute again the SH script like this, okay? Nothing special, so you just relaunch the script and the simulation is going to be reloaded from the initial state, okay? There we go. Now, let's continue reviewing our script. Okay. Here we are using another method, which is wait until nav2 active. Yeah. As the method name says itself, it's quite self-explanatory, but basically this is waiting for the navigation system to be active. Yeah. So, for instance, if we don't launch our navigation system, which we are doing here in the second terminal, yeah, our program is going to get stuck here, right? Then here we have a loop, a Python loop, that the only thing that we are checking is that the client library is okay, yeah? So that basically our node is okay and is running. And then here, we get the coordinates from our table coordinates, yeah? And we append these coordinates to a vector here. This root poses vector, yeah, that we are defining here. Okay, we append the coordinates that we have created earlier to this vector, to have them all inside this vector. Okay, and then we pass this vector to another method, which is go through poses. Yeah, this method, let me show it to you here from the simple commander API documentation. Actually, let me share with all of you this, because we are going to find some interesting thing here. Yeah, here you are going to be able to find all the methods. Yeah, for instance, set initial pose, go through poses, go to pose, follow waypoints. There are many methods that you can use. Okay, here in this case we are using this one, go through poses. Yeah, so request the robot to drive through a set of poses, a list of poses stamped. Yeah, this list in our case is these root poses that we are defining here. Okay, I saw some questions there. The coordinates are based on the laser scanned map. Exactly, yes. So the coordinates are based on this map. I don't have it now. the map that we were seeing in RVs, yeah, that is what is used as reference in this case, the map frame. For navigation, yeah, for navigation, always the reference frame is the map frame. Yeah, this map here. Okay. What else? Let's continue. Okay, yeah, so we call the go through process method and we pass our list of tables, yeah? And then finally here we have another loop where we are going to check if the task of going through the poses is completed or not. And meanwhile we are going to get feedback. In this case we are going to get the estimated time remaining, okay? So meanwhile, the robot is completing this task, yeah, of going through the different tables. We are going to be checking the estimated time until that task is finished. This is provided in the action message, because actually what we are doing here is to talk with an action. I'm going to show that to you in a moment, okay? Now, once the task is finished, here we have a reverse, which basically is going to start all over again. Okay, and then at the end we get the result from the action. Yeah. So why do we have? Why will we have this feedback and also this result? Because what we are doing is to interact with an action. And you might be asking, what action, Alberto? Okay, so let me show you that action. So let's start the navigation system again. Okay, we need to restart the navigation system again. Okay, and actually, let me start RVs again. And here, what I need to do is to compile my program. Yeah, I'm going to compile my program. Before that, I need to add the entry here to my setup.py. So let me do this in a moment. Right here, I need to add a new entry here. There we go. I need to recompile. Okay, Note that now I'm not going to, let me load my configuration file as I was doing before inside ROS2 workspace src pathplan.rbs. Okay? And now I am not going to provide the initial pose from RBs. Why? Because I am already doing that from the waiterbot navigator script, right? So let me execute my program here, and we are going to see some things now, yeah? So let me put this here so that we can see what's going on in our simulation. There we go. And let's execute the program, and we are going to move quickly to RVs to see what's going on here also. Yeah. So now my program is being executed, and the first thing I should see is that the robot gets initialized. There we go. And now the robot should start going through to the first pose. It's not going there for some reason. Setting initial pose. nav2 is ready. Okay, so the robot is not going there for some reason. Let me check the nav2 system. Failure to generate a path to. Oh, so here is the. I think this is the problem, and I think this might be because I didn't get properly the coordinates. Is that possible? Let me try. Let me try one thing. Let me stop this. Let me provide manually a pose somewhere around here. Let's go there. Okay. Okay, so there we have the robot going there. And I'm going to try to generate again the poses, because maybe I have something wrong there. So let me run again the get coordinates. Here it is. Get coords. There we have our robot. Okay, so right now, the localization system seems good, right? Seems aligned properly here with the map. So let me try again to put a point here, right where the robot is right now, which is first table. Second point, I'm going to put it here. And third point, I'm going to put it here, okay? So minus 2.84, okay, let me see what do I have here in my poses. Minus 2, minus 6, okay, this seems pretty reasonable. Okay, let me try these ones. Minus 284. Minus 595. 0, 0, it's okay. Minus 3.7. Minus 3.7. What else? 263. Yeah, this seems pretty okay. And minus 171. This one, maybe it's the problem. Because this looks like it should have been negative, and I have it positive. So probably this is the reason why. Yeah, maybe I got it wrong and I put this positive, right? negative, negative, positive, negative. Okay, it doesn't matter. And the Y's are all negative. Yeah? Oh, let me stop this. Let me see. Yeah, see? So it was negative and I was setting the coordinate to positive. So that's why I was getting the error. Yeah? You see? So be careful with that, okay? All right, so let me just restart everything. Let me stop here the simulation. Restart the simulation. I need to recompile here also, important. Recompile, Qualcomm build, there we go. We are going to restart the nav2 system. I see there that somebody in the chat already told me, Seba, yeah, exactly, so this was the error. Okay, let's come here to see our robot. Yeah, so let's launch our navigation system. Let's launch again ROS. Load our configuration file here. Open configuration, ROS to workspace, SRC, and path plan ROS. There we go. And now we run our program after sourcing, of course. There we go. Okay, so now we should see all over again how the robot gets initialized here, which is going to activate all the systems, the cost map, the laser, everything. And hopefully now we should see the system start sending the robot to the first pose. There we go. Yeah. So now the robot is being sent to the first pose. Yeah, the first table, which is the first coordinate that I entered. Yeah, we can see that the robot, and if we come here, we are going to see the expected time until we complete all the tasks, okay? And what I wanted to show you, let me open another shell here, is that what we are doing in this case is to interact with an action, yeah? And the action is this one. Let me show it to you right now. I'm going to leave the robot there completing everything. It's this action, yeah? Navigate through poses, okay? This is the action that we are using here in order to send the robot through the different poses that we have set here, okay? You can have a look if you want, for instance, at the type of this action, and you are going to find out all the different fields. ROS to action info, navigate through poses. Okay. Okay, and for instance, you can have a look at the message that is being used by this action. So, no, actually it's the server, sorry, it's this one. Copy. So, ROS to interface show. Yeah, there we go. It's a bit complex, but yeah. So as you can see, the goal, it receives a list of different poses, which in our case are the table coordinates. Here we have the result and the feedback. Yeah, feedback, there are many fields. The one that we are using here is this one, estimated time remaining. Yeah? Yeah? You can see it here. Okay, and here we have the robot, which is achieving the goal, almost there. And once it finishes, it's going to start all over again to the first waypoint and so on. Okay? See, so now it has finished it, and now I think it's going to restart all over again. Yeah, there it is. It is doing things. I think that yeah. This is, so the gazebo view is very delayed, okay? Because yeah, so the rosject computer is not very powerful, and here we are using some quite things with RVs, navigation system, and everything, and it's hard to handle. But yeah, so let me go back to the chat here. Let's review the last messages. My laser scanner, it is always transformed to the base link frame, so the distances are with respect to base link. What is first pose? Was interesting to see what happened and how to deal with the situation. Learned something. What do you mean, Seba? You mean the error I had with the coordinates? Learned a lot. Super. Okay, glad. Have you been able to replicate this? Did you have this working? Yes? No? Yeah, the error. Yeah. It's always interesting to have errors live and having to solve them. So it's something that roboticists we have to know how to deal with, right? Had it working, says Gilbert, also Krishna. Your internet is bad, Seba, so you have to listen. Okay, so don't worry. Then one last point because I have to finish already now. One last point that I wanted to say is that here, as I was saying, we are using the navigate through poses, yeah? But there is another action that you can use, which is the follow waypoints action, okay? Now, what is the difference between go through poses and follow waypoints? The difference is that in the go through poses, which is the one that we are using here, as you can see, the robot does not stop on the poses, yeah? So basically what robot is doing is to follow these poses, but it doesn't stop at each pose, at each coordinate, okay? So for that, what you could use is the follow waypoints. Yeah, in the follow waypoints also you are going to provide waypoints, but the robot is going to stop at each waypoint. And this can be interesting because then you can make the robot do something, right? At each table, or just stop there for a few seconds until the customers get whatever they need to get from the robot, okay? So the homework I would like you to do is to modify the program to use the follow waypoints instead of the go through process, okay? So that I'm going to leave it for you to work on this project, and it's the homework that I'm leaving to all of you, okay? So I'm going to stop all this now, and I need to close already. So yeah, let me say thank you to all of you for being here with me in this class. I hope that you have enjoyed it. I hope that you have learned something from this class. And yeah, thanks a lot, and I will see you again in the next open class. Until then, as always, keep pushing your ROS learning. Bye-bye.